students. Now we are going to discuss applications of MO theory. With the help of MO theory, we can calculate all these properties of complexes or molecules. So the first one, bond order, magnetic character, relation between bond order and other properties like bond strength, bond length, stability of the molecule. These are the applications which we are going to discuss with the help of MO theory. The first one, bond order. Bond order is nothing but the number of bonds between atoms in the molecule is called bond order, or central atom and surrounding atom is called bond order. So bond order equals to half into number of bonding electrons minus number of anti-bonding electrons. This is known formula. With the help of this formula you can find bond order. Instead of that, we can use, there is a shortcut for this. Suppose if the total number of electrons are 14, then bond order will be 3. Like N2 molecules, example for that, N2 means N plus N, 7 plus 7, 14 electrons. Similarly, 13 and 15 electrons, then bond order is 2.5, and 12 and 16 electrons, bond order is 2, 11 and 17 electrons, bond order 1.5, and 10 and 18 electrons, bond order is 1. Suppose if it is less than 10 or more than 18, then we can use this formula to find the bond order. And along with that, suppose if molecule is having resonating structures, then the bond length and bond order keep on changes. So for that we can use resonating structure formula to find bond order of those molecules or ions. And coming to magnetic character, so we know that energy orbital diagram up to 14 and above 14. So up to 14 electrons or above 14 electrons, there will be different order. So if you want all those things, you can watch the long video, or you can see that. So if unpaired electrons are present after filling molecular orbitals, then that is called as paramagnetic. Suppose if there is no unpaired electrons, that is called as diamagnetic complex. So coming to the next, relation between bond order with other properties. So bond order is directly proportional to bond strength or stability of the molecule, and inversely proportional to bond length. Like bond length increases, bond order decreases. So that is how we can decide bond order and other properties. Based on this point only, mostly questions are there in JEE Mains and NEET exams or CET exams. And coming to stability of the molecule, so there will be three conditions here. Bonding electrons, if it is greater than anti-bonding electrons, the molecule is stable. If bonding electrons are less than anti-bonding electrons, then molecule unstable. Suppose if any molecule have same number of bonding and anti-bonding electrons like Hc2 and Ne2, we can see those molecules doesn't exist. These are the overall applications of MO theory. Based on this, we can see questions also. Suppose you take example of N2, N2 plus, N2 minus 2, N2 minus 1. So here nitrogen have 14 electrons and N2 plus have 15 electrons, so 13 electrons, because plus means loss of 1 electron from 14, and this one have 16 electrons, 14 plus 2, this one have 15 electrons. The bond order according to the above trick, we can write 14 electrons means bond order 3, 13 electrons from 14 plus 1 or minus 1 decrease bond order by 0.5. So 13 electrons 2.5, 16 electrons 2, and 15 electrons is same as 13 electrons 2.5. So here bond orders we have calculated, and bond length how it will be, just inverse of this. So more the bond order, less the bond length. So we can write 2 greater than 2.5, 2 molecules are there, so that we can write like this. This is the answer for this. So that's all. Thank you.